Hello, everyone. My name is Austin Euchre. I'm a senior network engineer at Cox Communications, which is the third largest cable company in America. My current role is on the data center design team, and I get to work more with automation, which means I get to pursue one of my passions, which is helping others. And in this role, I get to help others through automation and building tools that help people's lives be a little bit easier when it comes to the operations side of engineering. So just to get right into it, the problem statement. So this is something that comes across my table, just different things of, hey, this is something we're working on. Is there a way we can automate this solution? Because doing this manually would be time consuming. So the problem statement is security requirement to change the fallback local login passwords on network devices at regular intervals and to treat local account passwords as break glass accounts, meaning if the password is viewed or used, then it must be rotated and stored in a safe location. So as you can see in this problem statement, to be able to do this at an individual device level when you're in a department where you could have thousands of devices, this would not be fun to do in a manual fashion. So that is why it was presented to me to try and design and come up with a solution or tool that could automate this for our department. So the solution I came up with was a closed loop automation solution. I know that's kind of a buzzword right now. So I'll just kind of explain how we're doing this, and I'll show a little flow chart on how and why this is closed loop automation. So just to begin with, to store the passwords, we decided to go with storing the passwords per device. And that is to lower the blast radius. So if someone were to use a password, then we wouldn't be required to rotate that password on all the devices using the same password. I decided that I would use automation to build the passwords and store the passwords and push the newly created passwords out to the network devices using service accounts, because they can't use the local accounts because that's the ones that are changing. So the storage location I chose was CyberArk, PAM, and this is because in our organization it's approved by a security team and it tracks the account activity, which I will need to be able to make changes or decide if a change needs to be made on a local account on a device. Ansible. Ansible is something that I love to use. It's the first automation scripting technology that I started working with as an engineer, and it's something I pretty much use for all my projects. And so Ansible is the tool I chose for the automation, and I'm going to automate the process with AWX jobs to run, checking CyberArk network device account passwords to determine if they have been viewed or are over a certain date and how old the password is. So then if either of these conditions is met, it's the password's too old or it's been viewed, then an email will be sent out to our operations team stating that a password is in violation. And also in this email will be a list of the devices that need to have their passwords rotated in both CyberArk and the network devices. Then the email will include links to more AWX jobs that can perform the task and make the local password security compliant once again. So as I stated, here is the flow chart. The flow chart just kind of describes how I'm going to implement the process and how it is a closed loop automation solution where it continues the automation. It's not just a one done. It's something that will be continued on and be a living script that is always running. So you can see at the top here the problem statement, local password rotate automation. The very first thing we have to do is create a local password account in CyberArk per device and add that new password to the devices. So I have a playbook that will do this because doing that for 1,000 devices would not be very fun. So I created a playbook. This is a one and done playbook that would onboard the devices into the closed loop automation solution. So then we get down into the actual solution. The first one is monitor local password accounts in CyberArk for any violations. This is something that I would have running in AWX or a cron job where it is running at least once a week to check for those violations. So let me come up into our first and really only decision in this flowchart. Are any of the accounts in violation? And remember, the violations were if the password is over a certain time old, or if someone has viewed that password. So if so, there will be an email of the devices with directions to address the violations sent to whoever I want it sent to. In this case, I'm going to have the email of our operations team, and it's going to send an email to them with a list of the devices that need to be addressed. The next piece of this is they would have to take the link that I send them in the email of how to fix the problem and run the next playbook. So this is where the little bit of manual intervention is. You get an email, then they go and kick off another playbook. So it'll rotate, and that playbook will rotate the local password accounts in both CyberArk and on the device. Then we're back to monitor. So then in this solution, if it monitored the next week and nobody viewed anything, there's no passwords that are over a certain time old, it'll come back up to the any accounts violation, and it should be a no. And it would just continue this process. If anything's in violation, it'll follow the yes, and if not, the no. So just to kind of dive a little bit deeper into each of those pieces in the flowchart. So the very first one was to create local password accounts in CyberArk per device and add new passwords to the devices. So you can see here, I just did a little snippets of the different places of where this playbook is touching. So there's an API call at the beginning that is going to reach out to CyberArk, and it's going to create these accounts, as you can see in CyberArk. And each account it has the device name, and then some notes, and then what safe it is in, because only certain departments should have access to certain safes for these devices. The next piece down here is the block, is just a task in my playbook, one of many tasks in the playbook of the API call of how it creates the account in CyberArk. So how does that account get there? This is how it gets there with this task in Ansible, a CyberArk API call. The next piece is, like I said, it's not only going to create the account in CyberArk, it's going to take that account and that same password and push that password out to the network device. So that's where this import role comes in. I have one for NXOS, I do this for Juniper, and I can do this for Arista at the moment. But just the first one I'm showing you is just NXOS, Cisco NXOS. In this role, it's actually going to reach out to the device, use some Cisco NXOS tasks, modules, and it's going to push the password, and it's going to also make sure that there are no other passwords on the device that shouldn't be there. So it'll do some cleanup for you if there is any rogue passwords, rogue accounts. The next piece in that flowchart was monitor. So we have to monitor the local password accounts in CyberArk for any violations. So you can kind of see in the background here, this is one of the more complicated parts of the playbook. This is where it actually does the comparisons. So I gather data from CyberArk and the API call, and I make some comparisons that compare and make sure that the last to see if anybody has viewed the account. If the last user to view the account was not my service account created to reach CyberArk, then it's going to be in violation. That means someone looked at this password and copied it or saw it. So then it's in violation. And I'll also check and see how old the account is. If the account is over a certain age, then it's going to also put it into this list. And then this list, if this list is has anything in it, then it's going to send that content in an email to whatever distro I point it towards. And in my case, I'm going to point it towards our operations team. And if this list is empty, then no email is sent, and we don't have to worry about it. But we know that this playbook is one that should be running on a weekly basis. So the next part is the email. So this is what the email looks like. I have that piece I showed you. It creates a YAML file, a violation output YAML file. You click on that to get a little bit more detail. But really all the detail you need is in the email itself in the body. So it just sends you saying there is a violation and it needs to be addressed. You can also find account info and the devices that need password rotations in the attached violation output.yaml file. So it'll tell you who put it in violation. So if you need that kind of information. And then to fix the devices that are not managed by CVP. So that's that could be a completely another topic. If anybody's heard of Arista CVP, I figured out a solution for the Arista devices that are managed by CVP. But if they're not managed by CVP, so that's our NXOS and Juniper devices, use this job template located here. I'm not giving where that is. That's something internal, an AWX job that I created. And then run this limit down here against that job. So once you do that, then it's going to kick off into the next part of the flowchart, which is actually rotating the local password accounts in CyberArk and on the devices themselves. So you can see in this little snippet here, it's going to generate a new password, which this also exists in the create playbook. I just didn't show that part, but there's the generate password for NXOS, and then I have other ones for Juniper and Arista and so forth. But there's a cool little module that you can use in Ansible. It's just a set fact and lookup, and it does this little cool random string, and then you can give it some parameters. It builds you a new password. And then I have this in a no log true, so that way anybody who goes to look at this playbook running, there is no log output for that password, because like, hey, well, isn't it already in violation technically? Well, no, because I have no log true set on the role for this task. Include task import role. The next piece is updating that password in CyberArk. So you can see we're going to go, I gathered the account ID per device, or for that device that is in violation that we put in the limit, and it got that account ID through another API call, and then we're going to take that generated password and update the credential. And once that is done, we have the new password. Then there's another task, just like the one I showed in the create one, that it uses the exact same NXOS task for pushing that new password out to the device, and also doing some cleanup if someone did put a rogue admin account on that device. So finally, we are back to the closed loop automation flowchart. So I just wanted to show this slide one more time before we go into the demo, so everybody knows what's going on. The very first part again is the create local password account playbook. This is the one-time playbook to onboard devices into this closed loop automation solution that adds the device and builds a new account in CyberArk for storing the password and watching and monitoring activities. And then it also goes and adds the password to the device itself. The next part is the monitor playbook. So that one is the one that's ran on a weekly basis, daily basis, monthly basis, whatever you want it to be, checking CyberArk for any account violations, which would be if the account is too old, the password on it is too old, or if someone has viewed that password. And if either of those show up as a violation, then an email will be sent to whoever you want it to be sent to with directions on how to address the violations. So then after that, you will be given a link to another playbook that will go and rotate that password or passwords on the devices that are in violation in both CyberArk, putting a new password in there that has not been seen by anybody, and on the device itself. And remember, like I said, everything I have in these playbooks has a no log true setting on whether it's on the role or the task itself, to ensure that the passwords that are created and pushed and pulled are not seen and cannot be seen in any logs as well throughout this process. So at this point is where I would show a demo, but I'm not going to do that right now. I am just doing this presentation as a proposal to AnsibleFest, and if I am selected, I will be able to show a quick demo on a C-Lab virtual environment of devices, including NXOS devices, Cisco, Juniper devices, and Arista devices, to show that this playbook is versatile and can hit multiple different platforms. We are now at the end of my presentation, and I just want to thank you for viewing it, and I hope that this is enough. And if it is, I hope to see you at AnsibleFest. Thank you.